Guys, so today we're going to be boiling some eggs for our experiment, and today we're going to be showing how the chemical reaction occurs when we are boiling with our eggs. Today we have our water, a cup of water. We have 2 eggs. We have our pot. We have salt, so we can add into it, and then we have our stove. Experiment. We're also going to be adding a form of African delicacy, which is called pando. It's a form of eba. It's a type of flaky powder that you use to put inside the water, and it forms with the boiled eggs, and you use it with our stew, and that's a form of delicacy. Experiment. We have our poster over there, which we're going to be explaining the chemical reactions. But first, I want us to start with actually like preparing the food, so we could show you how it forms. And first, we're going to be adding water inside the stove for the boiled eggs. It's kind of simple. You just add water to it. About 1 minute, you're going to put the fire on. You're going to make sure the water is going to be boiled so you could actually like boil the eggs. Add your 2 eggs to the pot. And in my family, we like to add salt to it. I don't know why, but my mom says it's like better for the eggs, so we're gonna just add like a little bit of some salt here. Not too much. The salt, we're just gonna let it sit there for about like, let's say 15 minutes. So like, time is 7:25, so like around 7:40, that's when we're gonna take out the eggs and cook heating up the metal. With the metal being heating up, the water is obviously gonna rise in this temperature. But you can notice here, all these little particles around the glass is due to the water evaporating, and that is due to the water changing its physical state from water to gas. And now you see here, as the container is closing up the gas right now, it's compressed. So if I was to release the lid, you would see the form of gas being emitted to the air, which is evaporation. So alright, so once I release it, you can notice that this is the water molecules I should say, and it's a form of gas and it's been emitted. Since the boiled eggs is done, we're gonna release it and try to cool it off. Some eggs being boiled, we're gonna try to crack it. So you're gonna take these and you're just gonna crack it and then release the shells so they could, eggs have been released from the shell, and you're kind of done right here. And then now we're on to the second part, which is the pando. And this is kind of complicated, but in the end, it's part of the experiment. It's gonna be the same type of ingredients, but instead of the eggs, we're gonna have this big jar of pando. First, we're gonna do is that we're just gonna grab this thing right here and try to take a little scoop of the powder right here. And this is the powder right here. And we're gonna apply it. We're gonna put inside the bowl. Just gonna put a little bit here. Make sure you don't want to put too much because it might look small, but when you cook it up, it's gonna be really big. So that's pretty much good enough. And you're gonna add water to the thing, and you're gonna add water. Not that much, but you're just gonna add enough, and you're gonna boil it. Try to get it into hot heated. I'm going to first of all clean my area. I'm going to pour the water in here. And when I pour the water, I want it to reach the surface of this bowl. I don't want it to overflow it, but I just want to reach the surface of this the pando right here. So we're gonna apply some hot water. Be careful. Alright, that is good for now. After you apply the water, I want you to let it sit in for about 2 minutes. And then when it's, it has changed its form, we're gonna add another set of water to it a little bit, and then we're gonna mix it. So we're not done yet. We're gonna first grab our ingredient, our instrument right here. And this is one Mom used to beat me with, but we don't care about that. We're gonna be using this we're gonna try to mix it up a bit, and then we're gonna add water is gonna be going inside the pando. And you're gonna do like a sort of technique. You're gonna hit it down a little bit in that form, and then you're gonna turn it up like that. It's hard, but you're just gonna hit it down and you're gonna turn it over. You're gonna be trying to add a little bit of some water while you're doing it, so you can get that nice mixture. Eventually, it's gonna form into sticky, flaky kind of in a way, but it's gonna be very soft. and the end product, and you're almost done here. It's gonna try to do the technique, and then you're gonna eventually smooth it up a little bit with some more water. You're gonna try to form it into a ball, and you're just gonna like roll it over with your hand, kind of like this, and you're gonna just squeeze it with your hands, and then eventually it's gonna form into a ball, and it's gonna be very smooth. This is Pando, and the end product is done, and then you're gonna grab your boiled eggs that we did earlier. I'm gonna get these right here, and then you're just gonna put it on the side, and that's how you make Pando with boiled eggs. But also with this type of African delicacy, we like to use a form of stew. So my mom cooked this stew for the experiment, and we're gonna take it out and warm it up in the microwave, and then you're gonna see the end product. Stew contains a little bit of some cow meat and some goat meat, and it has spinach and okra and a bunch of vegetables. The food being done, this is the end product of Pando, boiled eggs, and stew, and this is a form of African delicacy, like I said in the beginning. And overall, it's a hard process, but in the end, it's well deserved. As we have finished our food, like we said here, now we're gonna try to go into the chemical part of the experiment. And we made boiled eggs and eba / Pando. They're kind of the same things. For our ingredients, we needed egg, water, salt, a stove, fire, and eba. The three main ingredients that we're gonna be talking here today is water, fire, and salt. These were the three main things that we needed overall for both of the cookings, I would say. And these things are very essential in this experiment. For short segment, we're gonna introduce why eggs. Okay. Eggs, when you fry or boil eggs, is a chemical change which results in the formation of a new substance. The heat from the water causes the egg protein to change in the texture and the appearance, which is also called denaturing. The liquid state of the egg, which is the yolk, becomes a solid as you boiled it. Overall, with the added components that is inside the experiment, it's overall a phenomenal change. We're going to be talking about fire, and the chemistry term for fire is the rapid oxidation of a material in the exothermic chemical process. It could be in combustion or releasing in heat or light and etc. Fire as a process to heat up the stove, which also showed a lot of chemical components afterwards with the evaporation and the change in the eggs to liquid to a solid form, and the change of the physical change of the physical aspects of the chemical effect of combustion. We used it to change the materials that we started at the beginning to form this sort of African delicacy. Things in a stove, we obviously know that if you're to release one of these things, like for example the cap here, and take it out and then put on the gas, which is very dangerous, don't leave it on, it's releasing a sort of gas that you can smell through the, which I could smell, and it's a gas that we are used to start a fire. So we have the fuel right now, and then we have the water, which is under here. And the third thing we need is the heat. And the heat is basically, for this stove, is the electrical charge that we have when we flip on the switch. And you can kind of hear it, and you can kind of see if you look very closely. So that is an example of a fire. A fire is indeed a chemical reaction. The three things, which is water, we need the fuel, and the heat. And for that, we were able to form these. Second thing is that we need is water, which we use in experiment to for the boiled eggs and for the Pando. And for the water, the definition of water is a chemical compound consisting of 2 hydrogen atoms and 1 oxygen atoms. And here's just a basic balance equation of the formation of water, and you can see here that there's 2 hydrogen atoms and 1 oxygen atoms, and we added 2 here in front of the hydrogen atoms to balance out the equation, and those are called subscripts. Water is indeed H2O, and water is basically referred to H2O in a liquid state, which we use in the experiment. Water did indeed change it to a gas form. As the water was being heated by the fire, the molecules and the atoms of the water were changing fastly, they were moving quickly, which turned it into a gas form from liquid to gas, and that process was a form of a physical change. which was a part of the chemical reaction in our experiment, is that we basically just added salt to the experiment because we really needed it for the water, and we needed it for the food. And for the definition of salt, a salt is an ionic compound that can be formed by neutralization of certain acid and base. And NaCl is just a type of salt, basically. And with that, we need a sodium and chloride. Salt, which was sodium chloride, it is a ionic compound, and the ionic compound is in between the Na and the Cl, and that's sodium and chloride. And for the salt, we added it with the experiment, which it gives taste. People use it as taste, but basically the fundamental properties of this salt that we used was sodium and chloride. With salt being an ionic compound, we could go into depth in describing what basically an ionic compound is and how the association with sodium and chloride forms salt. So when we talk about like an ionic compound, it's basically when the ions with the atoms, they have a positive and negative charge, and they bond together. They bond together, it basically forms a ionic compound. One atom loses an electron with the other atom that they bonded with, which is ionic compound. With the sodium and chlorine formed together, it forms to sodium chloride, which is a chemical reaction as two separate atoms are formed together to form the formation of salt. So basically, the sodium that is the one that's losing the electron. So it's basically a plus charge right here. It's a plus. Chlorine is a negative because it is gaining the electron. So together they form a neutral compound because the ions balance each other out. Essentially, positive and negative charged ions must be balanced out in any sort of equation. So a visual process of an ionic compound, we could draw this as the atom for sodium, and we could draw the Cl as the other atom for the chlorine. Draw these for the electrons, just as a visualization. When these two atoms go together, the positive sodium is losing a valence electron, and the chlorine, which is negative, is gaining one. So you could show the transfer of one electron to the other one, and that is the chlorine right here. Essentially, it is showing the complete transfer of one or more valence electron during this chemical reaction of the formation of sodium chloride, which is salt.